Today's video is the distance between 2 points. We want to recall a little bit about the Pythagorean theorem that we learned before break. It's used to help find the length of the missing side of a right triangle, the formula being a squared plus b squared equals c squared. So if you're dealing with a right triangle and you see that right angle and you need to find the missing side of any of the either legs or the hypotenuse, as we recall, then you need to plug in the values of a squared plus b squared equals c squared into the formula. So we have here, we know that the two sides that come together to create our right angle are the legs. So this is A or B, it doesn't make a difference which one is which. So we have A here, B here, and we know that the side opposite our right angle is always the hypotenuse, which is always C. So plugging in our values, we have x squared equals x squared plus b squared, which is 2, and c squared, which is 7. So plugging that in, and then we solve for x squared plus 4 equals 49. Subtract 4 on both sides because we need to get x by itself. X squared equals, we have 45. Now, in order to find the value of x, we take the square root of both sides. Now, the square root of x the square root of x squared is just x. The square root of 45 ends up being a decimal. So right now, for our sake right here, we're going to end up leaving it as the square root of 45 because it doesn't state to round to the nearest hundredth or anything like that. But if it does, you would go ahead and calculate that and round to the appropriate place value. Now, another way of finding the distance between 2 points, because remember, in a triangle, we have points here. Each corner is a point. So we can use the Pythagorean theorem. If you're dealing with a coordinate grid, you can use a Pythagorean theorem to find the distance between our point here and point here of any line, okay? But we can also use distance formula to find the distance between 2 points if, per se, we do not know, we don't have a graph that we can use that has the nice coordinate grid where we can count the boxes and so on and so forth, or if we're just given 2 points just randomly with no graph being found. So we use the distance formula, which is the square root of the x values, the difference of the x values squared, plus the difference in the y values squared. So once we find those, and again, using PEMDAS to help us solve our problem here, our steps here, first step is to identify the two coordinates and label. Labeling meaning we want our x1, y1, and our x2, y2. Okay, we want to label so this way we can produce them and put them appropriately where they go in our distance formula. Then we're going to substitute the values into our formula. So take those labeled values and plug them in. Subtract is the first thing that we're going to do. Square our difference, add those two together, and then take the square root of that. Rounding if necessary, and don't forget the dimensions if you're given any dimensions like if we're trying to find out how far these 2 points are in feet, centimeters, meters, and so on and so forth. Not always given, but just in case. Now, for model number 1, we want to find the distance between the 2 points, 1, 2, and 9, 8. So we have x1, y1, x2, y2. So utilizing our formula, we identify the two coordinates and we label them appropriately. Now we're going to plug them in and substitute them into our formula. So we have the square root of x2 minus x1. So x2 is 9 minus x1, which is 1, squared, plus y2, which is 8, minus y1, which is 2, squared. So we're going to now take those and we are going to subtract. So we have 9 minus 1 is 8 squared plus 6 squared. And we have 64 plus 36, which is 100. And the square root of 100 is 10. Any questions? Let me know.